time. Well, let me just put it here.
Wait, what? Oh, if you weren't here last
Yeah,
time.
yeah.
Okay. What's the problem with
Do you guys have any questions from any homework problems? We're gonna get to play with some stuff today, so.
Yay!
Can we go over test problems, just different numbers?
Sure.
Okay. I wanted to look at number 7, like this number line thing I'm having a hard time with. Can I draw it, what I did in
Yeah. You got it?
I just did this, asked it for help in this problem.
It wants us to use a number line to calculate 7. Seven divided by half. So what I did was, also stop me if I'm wrong, please.
So far looks good.
Okay. And divided by 1/2. If these are wholes, I did something like that.
Why did you start there?
Why'd you start at 1 instead of 0?
I kind of regret coming up here right now, actually. Hold on.
You're doing good. Just start at 0.
You're a good gamer.
That's where I went wrong. Okay.
That's
Start
where you
at
went
one.
wrong. I remember yours now. I think the
Yeah.
first thing was a 1, yes?
Yes, I
And
should have
that's,
started
yeah,
at 0.
so start at 0. You have the perfectly right idea, right?
Yes.
And on a problem like that, like how would you do it? How would you do it just directly? Without a number line. If I just said do that, what would you do? How do you divide fractions?
You keep it, change it, flip it.
Yeah,
So-
so 7.
7 times 2
Which is
over
2.
1, which would just be 2.
Yeah. Yeah, 14. So you know the answer should be 14.
Okay. And
So whenever I ask you to do something you never would do, but it's just because it's a explanatory way to show students, you can, on the side, you can do the work to know what the hell the answer is going to be. So you know if you're doing it right.
Yeah,
as you do
because
it,
my
yeah.
line started here.
Yeah.
Yep,
Okay.
always started at 0.
So let me ask you this. What would somebody have done if Ramondo was your student and he came up to the board and you started doing that?
I probably asked them first, like, okay, if, like, using the number line and stuff, obviously I'd probably first ask, why'd you start from 1? Think of it like this, we're starting from, like, a complete base, which is normally 0, because it's not positive, negative, whatever.
Yeah.
What they know. I would just be like, how many halves are in 1?
Yeah, okay, good. So you can, I like it. So the main trouble was we left this part alone. So then you could make the problem different. What if it said 1 divided by half? Then it becomes apparent that this part is important. I like it. Now what if somebody got this and didn't even know where to start? One thing we learned earlier this semester was when you have to do a word problem, you can try to solve a simpler problem. So as a math teacher, what I very often do is if there's a problem, somebody is not sure how to do it, I simplify it, make it a simpler problem. How would you do 6 divided by 2? Come over here, Jim. How would you do 6 divided by 2 on the number line here? There's kind of 2 different ways you can do it, but
4, 6.
yeah, how many steps of 2 can you take? 1, 2, 3. And that's one reason why 6 divided by 2 is 3, correct? Once you show them, remind them about that, how many steps of what do I want to take? So over there I took steps of 2, here I want to take steps of a half. So then 1, 2, 3, and yes? So you need, as a teacher, you need to recognize when the problem is at a higher level than it could be. So if a student's having trouble with the problem, take that step back and say, okay, let's look at this problem. Now, everything you just did, do exactly the same thing. with the harder problem. So that happens all the time in mathematics. Okay. Yes.
Is that what we're doing, or are you about to get into something?
Huh?
Are we just like asking?
At the moment, we're just asking questions, and at some point, I'm going to stop us and we get into the
Right.
lecture. Yeah. But yes.
I can't tell what we're trying to spell here.
Who knows?
Last, least,
LCD.
LCD, okay.
Yeah.
It's coming, coming,
Red coming the mum on the mum.
coming, dun, dun, dun.
Denominons.
Dun, dun,
Bum,
dun,
ba, da, da, da.
Bum.
All right. Any other questions before we get into new stuff? So we've only got 2 chapters left, which is good because we only have 1 week left, really. Next week, and then after that's going to be so the last couple chapters. I'm going to focus on chapter 8. Chapter 9, we're probably going to end up not doing the entire thing, but I'm going to talk about most of it.
Did you say we're gonna do homework for chapter 9?
I haven't said that yet.
Oh, I thought you
You talked about it, you just haven't fully confirmed it yet.
Yes.
But don't worry, it's gonna happen.
Do not despair.
I'll
We
give you
will
a
have
dollar.
What did she throw?
Are you, a dollar's like 90% of a teacher's pay.
What's up? Sorry.
It's very sad.
A dollar's like 90% of a teacher's pay.
Oh, if that was true, I would never be able to make it in California. You'd see me, yeah, it wouldn't be good. So what we're about to get into is we're finally going to recognize that negative numbers exist. Yes. So chapter 8 is all about integers. So let me talk real quick about this.
Oh.
What's up? Interesting reaction. So very quick word about types of numbers. Does anyone know what the natural numbers are? Yeah, Mason.
Isn't it ones that we just found naturally, just do like the 0, wait no, 1, 2, 3, 4.
Yes, natural numbers are 1, 2, 3, 4, right? We talked a little bit about the fact that the 0 had to be invented. The idea of 0, the symbol for 0 had to be invented. So natural numbers are 1, 2, 3, 4. Things that came naturally. So you got the caveman, he's got 2 rocks. 1 rock, 2 rocks. All right. Then we had to invent the idea of 0. So one day he loses his rocks, and now he's got 0 rocks. So I had to come up with the idea of 0. I know. Still can't get over it, even though it's about 10 million years ago. Then he had to borrow a rock, because you can't get by without a rock. So he had to borrow a rock. So he had to come up with the idea of negatives. That's where we are now. We're in the integers. So before today, the book was always sort of pretending like negative numbers didn't exist, which is a little frustrating. Yeah. But now we're fully accepting that negative numbers exist. What's the only number that's not negative or positive?
0.
0. Cool. So 0 is just itself. It's its own thing, right? So how do you represent positive, negative numbers? Have any of you ever seen the movie called Stand and Deliver? Stand and Deliver. It's a true story about a math teacher who took like a very basic math class and took them all the way through calculus. It's a true story. It's really awesome. And there's one scene in there where they're talking about different sign numbers. So if you had to represent something like -3 + 5, right? How would you try to represent that? It could be a physical situation. Yeah. Okay, so computationally, so let me do this then. Just there.
Well, no, move it.
I know. But still, what about this guy? How would you represent this physically? Yeah.
You already owe 3.
Good.
Now you also owe another 5.
Beautiful. I love it. And that's actually a beautiful way when somebody says 2 negatives make a positive. What do they actually mean? When did 2 negatives make a positive? When you multiply. I love it. So later we're going to talk about multiplying sign numbers. But when you combine 2 negatives, you can't get rid of the negative. I've tried it, right? I got debt here, debt there. They don't cancel the negatives. I'm like, damn it. They just add on to each other. So one way is exactly like Elizabeth said. I owe you $3. I owe Mundo $5. So how much do I owe altogether? $8. And I like my thumbs, so I'm going to pay him off eventually. Okay, you guys got it with me?
We take care of him.
anybody have a different, so money is always a good way to go. The younger the student you're talking to, the less money is going to be applicable, right? What's another physical representation, do you think?
I like the two colored coins.
Sure,
You have
okay.
the 3 blue coins, and you have the 5 red coins.
This is going to unfortunately be black. This is what, yeah, I don't have black little chips. But normally, do you guys know in the black? Do you know that's a good thing? That means you're making profit. So back in the day, your parents or somebody might have had, or maybe grandparents, I don't know, the little adding machines. And if it was a minus, it would print in red. And if it was plus, it would print in black.
Oh, they used to
Okay.
use that machine.
Oh, that's why it's
Yeah,
in red.
yeah. This is how old Jeff is. So, if I want to represent negative numbers with physical things, I could represent them with red chips, for example, and positive numbers would be, in this case, blue. Yeah. But for this guy, another thing is, I always like to think of digging a hole and climbing back up. So if I dig a hole 3 feet down, and then I dig 5 feet further down, how far down am I total? 8 feet. And so somebody could have that. I always say, envision next to you this happening. Somebody digs down 3 and they dig down 5. Now they're 8 feet down the hole. You can actually see it happening. So it's a very physical image you can kind of conjure up.
And then they start shoving you in the hole and
Yeah. So this would be down 3, down 5. This would be, what would this be? If I dig 3 feet down, so I'm standing in the hole. You with me? Maybe somebody puts a ladder in there, and I climb 5 feet up. So how far above the ground am I now?
2 feet.
2 feet above the ground. You guys kind of with me? So this is a very physical interpretation of the mathematics. I like it. So this is 3 feet down, climb 5 feet up. So of course now I'm 2 feet up in the air on the ladder. Okay, I like it. I might keep. There's a kind of a rule way to do this. So let me show you this. This is the physical interpretations are very, very helpful. But if you want to make kind of like a computational set of rules, there's 2 rules, just 2. When I'm combining signed numbers, combining integers, if they have the same sign, add and put the sign back on. So for example, the one we just did, negative 3 minus 5. What's 3 plus 5? 8. So then I put the sign back on, negative 8. Kind of makes sense. If I have debt, I have more debt, my debt's adding to itself, right? Of course, you already know if I have 2 plus 4, they're both positive. You get 6, and then you put the sign back on, it's still positive 6, right? So if they have the same sign, you add the numbers and put the sign back on. What do you do if they have different signs? So like negative 3 plus 5. You give me the 3's negative, the 5's positive. Yeah, exactly. You subtract them. So 5 minus 3 is 2. And then you put the sign of the bigger one on. So in this case, it would be positive. I like it. What throws people off is we don't normally write the plus sign. Right? So when there's no sign there, it's understood to be positive, but the negative shows up. So it gets really confusing, the difference between a negative number and subtraction. Right? Math doesn't look at them as any different, but it kind of messes us up if we look at it the wrong way at the wrong time. How are we doing so far? This is, when I was teaching Math 88, back in the day when we were allowed to teach that, these 2 rules really cleared up a lot of stuff for people. It was just it's only 2 things. There's only 2 possibilities. Okay. So now let's get into this. I'm going to show you a few things up on the overhead. We'll slowly get to a point where you can do some of this stuff. And so if I want to represent -4, oh yeah, I do have a red pen. Doesn't matter, Jeff, you have the stuff too. I could represent that as a set model. For negatives, right? So that's -4. If I want to represent 3, that's crazy size. So if I want to add -4 plus 3, how do I do that? What do I do? Set model wise.
They kind of cancel each other out.
Yeah, totally. So if I put them together in one big ass thing, let me put my plus there and then my negatives. You guys see the negatives? Yes. Like Mondo said, a plus and a minus cancel. Now that's a whole side note, is why does a plus and a minus cancel? On one level it should be kind of intuitive, right? But just a little side note about that by itself. I think this is later.
The plus is like getting back, but the minus is taking away.
Yeah, if you think about it like a measurement model.
They're like bouncing.
Hey. I know. I didn't draw them. Sure. See you, Susan. Plus 1 would go up 1, yes. And of course, -1 would go back 1. So they do end up canceling each other out. That makes sense. You can also think of it again. You can do money. In the scene in Stand and Deliver, that movie, they say what's -1 plus 1, and the whole class is trying to help this kid out. They're like, fill in the hole. So if you think about digging a hole 1 foot down and then putting 1 foot of sand in, you fill the hole in. You're back to ground level. You're back to 0, correct? So the whole class is chanting, fill in the hole. Anyway, it's a nice point. So each of these is going to do what?
Cancel.
Yeah. So then you're left with one poor little negative. And incredibly enough, that's true, because -4 plus 3 is negative. So this is a visual representation of that problem. I like it. So we've got these symbols, of course, so we don't have to constantly be drawing stuff. Oh, sorry. I don't know if you guys are still copying that. So I've got, here's -4. And then if I got +3, just throw 3 down, and then these kill each other. And then I got my -1. Cool. Now we're going to be doing multiplication, division with this stuff. It gets kind of nifty. Should I just stay up here? Probably. Alright, so we're going to play with these chips in a bit. We don't have any cards, so we're not going to gamble. Sorry. Oh, I did all that. That's awesome. Yeah, so if I want to talk about the opposite of a number, let's say the number is A. What would the opposite of that be?
-A.
Yeah, good. There's a problem with the word opposite though, because what's the multiplicative inverse of A? 1 over A. So when I say the word opposite, it could mean 2 different things. It could mean multiplicative inverse. Now what do you guys think? Why real quick, little remembering of things. Why is 1 over a the multiplicative inverse of a?
Reciprocal.
True, but why is it the multiplicative inverse? What happens when I multiply? It becomes the multiplicative identity, correct? So this, I can't remember if I told you this yet or not. If there's a multiplicative inverse, there's almost definitely an additive inverse. So what do I add to a to make it become 0? Negative, totally. So that is what we consider to be the opposite of a, but you can see how just saying opposite is not good enough. The opposite could mean multiplicative inverse or it could mean additive inverse. Yes?
The way that I was taught was that the opposite means like on a number line, like on the opposite end.
Yeah. So the additive inverse in this case, I'll talk about this in a minute, but I'm just going to do this. So a would be exactly like the mirror image on the other side of 0. Yeah. I like it. Now, real quick side note. Don't. Let's see what you guys think. Is this a negative number?
Yes.
Possibly.
Why possibly?
Well, A could technically, we don't know what A represents.
Totally.
So it could technically be a negative 3.
Yeah. So if a is negative 3, what is negative a?
Positive 6, positive 3.
Positive 3, yeah. So it's just because I don't know what a could be. It could be negative, it could be positive, but I do know this is the opposite of it. Additive inverse. So the opposite of negative 3 is 3. So that holds. Okay, I like it. That's a quick little side note. So let me see if you guys are cool with this. If I want to do negative 4 plus negative 2, and I want to do it set notation, set model, how would you do that?
4 negatives.
Yeah, 4 negatives, 2 negatives, and then if you throw those together, 6 negatives. Okay, so that's beautiful, that's nice. And again, that's a beautiful place to start. When you're first introducing negative numbers, you show students they work the same way as anything. If I add so many negatives, I can get how many negatives I've got. The same way we add anything. 4 chairs, 2 chairs, 6 chairs. 4 negatives, 2 negatives, 6 negatives. Then you can kind of build up to stuff like 2 plus negative 5. So try to represent that set model. So no, on one level this is kind of simple because we all know the answer already. But it's interesting to try to see what does it look like this to people that have no idea how to do the problem directly. So how do we represent 2? Plus plus and negative 5?
5 minuses. And then bring them together.
I like it. So now if I throw them together, I get plus plus, and I get minus 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 minus.
Slash out the 2 plus minuses.
These go away.
War.
Yeah, so that's a nice physical example of why that answer is negative 3. I like it. Now, real quick, I'm doing this out of order and it almost doesn't matter. This specifically is different physically.
Yes.
We know these are the same thing, don't we? But again, we've already worked with this stuff. I need to show somebody these are the same thing, but I need to do exactly what the physical requirement. What does this want me to do? Whatever number I put there, what does this want me to do? Take 5 away. And as a human, new to this world, you're gonna have a major problem with that. I don't have 5 things. So let me see. So if I start with 2 things, And this problem, Jeebus, Jeff. If this problem wants me to take 5 of them away,
You would go into the negatives.
how do I do that? Let me redraw this because I can't make a plus sign even. That's pretty bad for my profession. So remind me, what does this represent? If I ever see this, this here, sorry. What is that? 0. Beautiful. Can you add 0 to anything in the universe and it stays the same?
Yeah.
Will a student know that by the time you're talking about negative numbers?
Probably.
Yes, they will. They have to. You will have talked about additive identity already, right? Plus 0. You guys all with me? I can add as many frickin' zeros as I want to. Notice, if I add 1 0 in, don't I now have 3 pluses? If I add one of these in? Well, how many do I need? How many does this crazy ass problem want me to take away? 5. So how many do I add?
3.
So I have the 2 I started with, and then I add 3 of these. Does everybody understand what just happened? I need you to understand. I totally understand that the level of math is very low, but what just happened is so freaking cool. I added 0 3 times. Does everybody agree with me?
Yes.
Plus minus is 0. Of course it is, Jeff. They freaking cancel each other. What do you do? But now do I have 5 pluses? Can't I do what the problem wants me to do now? What do I get when I take those away? Because it wants me to take 5 away. What do I get?
3 minus 3.
Minus 3.
Yeah, which of course is what 2 minus 5 is. That is nifty. Okay, maybe. Alright, so I'm going to give you these in a bit. I'm going to ask you to do several problems. And so you're going to get one like this. Okay, I like it. Alright, let me see. I've skipped over a few things. Let me see. Blah, 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 blah. Okay, did that. Blah, 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 blah. Did that. Blah, blah, blah. Ah, okay. Remember all the properties? We've talked about them several times. Every time we kind of come up against like whole numbers, fractions, decimals, we remind us of all the properties. Give me one property we've discussed. Get it started, Mason. One.
Associative.
Okay, associative. Commutative. Give me any other one. Any other one.
Distributive.
Distributive. Okay, I love it. So we got associative, commutative, distributive, kick ass. Then you've got, for example, additive identity, multiplicative identity, yes? And then the stuff we just talked about. Additive inverse, multiplicative inverse. Okay. I'm pretty sure I've talked about this before, but officially this is one that we know now. That's the only new thing, is we allow the additive inverse to exist. Because according to the book, before we got to this chapter, negatives didn't exist. Okay. So all those should sound very familiar. I'm pretty sure I said additive inverse before, but now we officially know it. You guys remember what each of these means?
Mostly.
What do these work for, though? Let me see. What operations do these work for? There's only 2. Is 7 plus 3 equal to 3 plus 7?
Yeah.
So addition seems to work. Is 7 minus 3 equal to 3 minus 7? Nope. So subtraction doesn't work. Is 7 divided by 3 the same thing as 3 divided by 7? Division doesn't work. Is 7 times 3 the same thing as 3 times 7? Yes. So multiplication seems to work. So it's these 2 that they work for. And very quickly, just to blow your mind a little bit, subtraction does not exist. It's just adding the additive inverse, right? So if I want to subtract 3 from 5, I just add negative 3 to it. You guys are all with me. You're all like, what the hell, Jeff, man? I got a minus button in my calculator, alright? Subtraction exists. but I'm just trying to let you know. In reality, it doesn't. It's just a quick shortcut we created. Let's call this operation of subtraction, just to shortcut it. Yeah.
So math is just all addition.
Yeah, because multiplication is repeated
Yeah.
addition. So yeah, at the heart of it, that's why computational machines, they're all built on the basic operation of addition. And then you can build on top of that, but every single operation comes back to addition. Yes. Okay. Describe that to me.
Adding.
Yes. Okay. Just stay with me now. Stay with me. Stay with me. I know. I'm boring yourself. We're gonna get to the point where we can play some stuff. Let's talk about subtraction now. Let's officially talk about subtracting signed numbers. Why is there space there? I don't know. Subtraction. So if I had to do, what do you think about this? -3 minus -2. Now I know all of you should know kind of like computationally what to do here. What do you do here computationally? Does anybody know what to do?
Plus,
See it?
change the,
Yeah, the two negatives make a plus. So let's pretend like we don't know that. Look at that more basically. How many negatives do I have at the beginning? 3. I got 3 negatives. How many negatives am I taking away?
2 of them.
So of course, how many negatives should I have left?
1.
So that's -1. Do you understand?
Hold on. You said that part again?
Sure. When I say at the beginning, I mean here. So here I am, nothing's happened to me yet. I have 3 negatives, correct? Now somebody's taking away 2 of those negatives.
so you have 1 right?
So I have 1 negative left,
Oh,
so
when
the
you meant
answer is
three
-1.
negatives, you weren't talking about the 3 negative signs, you were actually talking about the number.
I'm talking about the number 3. Yeah, I have 3 negatives,
Yep.
right? Because what's -1 plus -1 plus -1? -3. So I have 3 negatives, and somebody's taken away 2 of them. Damn them. You guys with me? I'm not saying you have to look at it that way. I'm saying physically, that's what this is. So one way to look at negatives is they're just collections of things. Like 3 means a collection of 3 things. -3 could mean a collection of 3 different things. So if I have 3 of the negative things and somebody takes 2 of them away, of course I got 1 of the negative things left, right? And then when you build up to the point where these do become plus, yes? And then you could do -3. All right, let's do this both ways. If I have -3, and this tells me to take away 2 negatives, correct? So then you just physically do that. So of course the answer is -1, yes? If I rewrite it like this, what is this telling me to do? Here's my -3. What's this telling me to do?
To add 2.
Add 2. And of course these all cancel. So of course I still get -1, correct? Are you guys at all with me? No. Okay. But that's a nice physical representation of 2 negatives making a positive. So quick side note, why do 2 negatives multiplied make a positive? So I think I've told you this before. If I multiply 1 by -1, it's a rotation. Have I ever told you that before? If I multiply any number by negative, doesn't it switch the side of 0 it's on? So you can think of it as a rotation. Are you with me? Do you agree? If I multiply 3 by -1, where does it end up? What's 3 times -1?
-3.
Then you rotate over here. You with me? So if I multiply any number by -1, it will just rotate to the other side of the number line. That is a weird ass way to say that. Do you guys agree? I am aware of that fact. I just want you to know that I know. That's a weird ass way to say that. So what if I multiply -3 by -1? Well, I'm multiplying by -1. We know the rule is supposed to rotate to the other side of the number line, right? So what's -1 times -1? 1. There you go. Okay, maybe. Another way to say it is, if you call multiplying by negative turning around, right? Does it make sense? I'm facing this way, so negative this would be me facing that way, yes? So what if somebody says, okay, negative, negative 1. Okay, negative 1 is this. Negative that is turn around again. I'm back to 1. Does it make sense? So you think of multiply by negative as turning around. And again, do you see how it's basically the same idea of rotating? You guys at all? So, by the way, just a quick side note, do not freak out. Did I show you that video? With the people talking about the apples and the anti-apple? No? But they picked up the graph and it was small. Okay, maybe not. Okay. That talks about complex numbers, which might be why I decided not to show you that, but it's still a cool video. This idea of rotating, how many of you guys have ever heard of complex numbers? Okay. The eyes, remember the eyes?
Yeah, imaginary numbers, pi, phi.
This isn't me making shit up. This is the reality because I'm not going to get into complex numbers. But this idea of like rotating, if I only rotate halfway, that's an imaginary number, right? But if I rotate the full way around, they stay real. That's why imaginary numbers are kind of weird. Okay, enough. Sorry. So I just want you to know this thing I'm doing that looks like a rainbow now. It's not just me doing weird shit. This is actually the math behind this. That is really what it is. That's a full rotation is multiplied by a full negative 1. If I multiply by half of negative 1, which is the square root of negative 1, that's a quadrature. Yeah. Okay. Enough of that, Jeff.
Wait.
Yeah.
Then would math work different if we were 4th dimensional?
Well, I mean, we are.
No, we're
Probably 10th dimensional.
No, we're 3 dimensional.
We're 10th dimensional.
How are we 10?
Yes, we are.
Clearly you haven't traveled outside.
Let's look this up.
We talked about that in chapter. No, we didn't. Okay.
I'm surprised we didn't do any graphing in this class.
Huh?
I'm surprised we didn't do any graphing in this
It
class.
says we live in a three-dimensional.
Yeah.
We live in an observationally three-dimensional world. 7 dimensions are tightly wound. We don't even see them.
Simpletons.
Stop.
I am so confused now.
I'm sorry. You said it. I had to go somewhere. I had to go with that. Alright, no good. Okay. Okay. So when I multiply two negatives, it becomes positive. That's cool. Okay. I like it. So watch this. So I just want to do a little example of, you can think about this directly. You don't have to make this into a plus. We sort of automatically do that, but this just works directly like anything does. 3 negatives, take away 2 negatives. Of course I got 1 negative left. I don't have to do anything extra to it. I don't blame you if you do. A little shortcut. So here's general something about subtraction. What's 5 minus 2? 3. Holy shit. What's 5 minus 1? 4. Did it get bigger or smaller? Bigger. What's 5 minus 0? 5. So have I established a pattern now? If I subtract 1 less, of course the answer gets 1 more, correct? Okay, so what's 5 minus negative 1? Without thinking. Continue the pattern. 6. Does that check? You just talked about this. What's minus negative?
5.
Yeah, 5 plus 1? 6, check. But this is a really kind of a nifty way to show that it just naturally makes sense if I continue going down. Now here's a physical interpretation of this. Let's say I have $5 because I owe somebody $1, so I'm not counting that buck I got. You guys kind of with me? Say I'm thinking I got $5, and then they forgive my debt. Doesn't that make the amount of money I have go up? So this is like subtracting a negative. Why is it a plus? Because it actually ends up taking away what you owe, so you end up with more money. That's another physical interpretation of minus and negative. Okay. So if I want to do, I think we already did one like this, but just very quickly. If I want to do negative 4 minus 1 with set notation, I keep saying set notation, set model, I could literally just take, if I want to do negative 4 minus negative 1, Jeff, there you go, buddy. Negative 4 minus negative 1, I could just take one of these away, and then I'm left with negative 4. So that's the one we just talked about earlier. Can you guys, let me see who was paying attention earlier. Can you do 3 minus 5 set notation? Set model, sorry.
You want it? I don't read it for.
You got it? You want-
Yeah.
What you got?
-2?
Hmm?
-2.
No, let's tell me what you did.
Oh, I put a plus minus, plus minus, plus minus.
Well, what do you start with though?
Oh, 3 pluses.
Alright, start with 3 pluses.
And then another circle for 5 minuses.
Oh, so to be really careful, you're doing this, which we know computationally is the same as this, but I want very specifically, physically, what does this want me to do? What does it want? It wants me to take 5 away from 3,
Yeah, so you keep,
which is not difficult to understand why humanity was confused about that. We're like, I don't have 5 things.
Oh, add the equals, the plus minus.
So I got plus, plus, plus.
Yep.
So then I add how many?
2 of them,
Yeah.
plus minus. Then we start canceling.
Mason Elizabeth, I know you knew that, so thank you.
yeah, that's confusing for me.
Huh?
That you're adding the zeros to prove that you get the -2.
Totally. And again, I need you to understand from a child's perspective. If they have 5 trucks and I take 2 of them away, they can see that happening. Sorry, they were getting upset. Are you guys with me? If I have 3 things, 3 trucks, and I want to take 5 of them away, what? So, in that situation, you can think I could borrow 2 trucks from somebody, they can take 5 trucks away, and then I still owe them 2, so that's -2. So that still works for the trucks. But up here, that's the same idea. If I add 2 trucks at the same time I add owing a truck, 2 trucks in this case. So every time I add a truck, I owe a truck. Add a truck, I owe a truck. Because I'm borrowing that truck, yes? That's another physical way to think of it. It's my favorite sound, by the way. Oh. So here, can I now take 5 away? Euro. So then, of course, I end up with what we all know the answer is. -2. Yes. So I understand about the, it's weird to introduce something that wasn't there. But I could add 0 all frickin' day long. So what's really funny is you get far enough up in math and you start to know all the different representations of 0. Because in different situations, if I add a certain representation of 0, it makes the problem easier to do. So all we're doing here is we're adding 0 until, oh, I've got what this guy wants. Now I can see the answer. I like it. Okay, so how would I do this then? Very directly. 6 minus -2. Don't make it plus. It's just the same idea, just the other way around.
Ooh, I like
In
that.
set model.
Huh?
In a-
Set model, yeah, set model, sorry. So the other possibility for model would be the measurement model. We could do this stuff on a number line. It's never quite as interesting. So the problem up here was, I'm trying to take 5 positives away, and I only had 3 positives. The problem here is, I'm trying to take 2 negatives away, and I don't have any frickin' negatives at all.
This side.
So I start with 6 positives. What do I have to introduce so I can take 2 negatives away? Yeah, a plus, minus. So now I can take 2 negatives away, yes? Not sure why I'm writing so tiny. Is anybody at all, I'm sorry, I'm always like, this is so cool to me. This is so basic. This is so basic, but it's so cool to go, yeah, I can just add a plus and minus. Now I can do what the hell the problem wants me to do directly. I know we all know that 6 plus 2, it's freaking 8, Jeff. Dear God, Jeff, it's just 8. But this is so stupid cool. It literally wants me to take 2 things away that I don't have. So I go to somebody, I'm like, I need some negatives. So now can I take 2 negatives away? Yes.
So you just say, you just put the negative in
As long as I put a negative and a positive,
there.
I'm golden, because I'm adding 0. So then how many pluses do I have left? 8. So 6 minus negative 2 is the 8 that I knew you all knew. I like it. Okay. And again, this is where I get a student that would say, my God, dude, that's an easy problem. What are you doing to me? But this is the bridge to students who are thinking purely physically. They can't think. The minus and negative becoming a plus is actually a higher level concept. I need to be able to see them and then take them away. I need to do that physically. So that's what this does. Okay. Can somebody tell me, we're going to bring back some earlier stuff because we're subtracting. We've done subtraction before. What was one approach to subtraction to figure something out? Like if I wanted to do, like back in the day, if I wanted to do 8 minus 5 equals what? How can I turn that around? And what's that called? Missing additive.
It's 5 plus 1.
Yeah, so 8 minus 5 equals some number if and only if 8 equals 5 plus that number, right? That's that missing addend idea. So of course that still works now, even with the negatives and positives. So here the end would of course be 3. That's crazy, Jeff. So what if I had to do 7 minus negative 3 equals what? What's got to be true then? 7 has to equal, same way we just did this.
7 equals.
No. Rewrite like I did up here. If
M
8
plus-
minus 5 is something, then 8 is something plus 5.
So it'd be.
If 7 minus negative 3 is something, then 7 is something
Less negative?
plus negative 3. That's the missing addend approach, yes? And what do I add negative 3 to get 7? No? 10. Add negative 3 to it means subtract 3, right? You with me? So m would be 10. And of course you could always just do it directly. 7 minus negative 3 is 7 plus 3 is 10. Okay. Right. Okay, let's get into multiplication. In fact, yeah, let's do this. All right. You'll be very happy. I'm going to stop talking for a while. I'm going to make you guys do a few problems. We're going to build up to multiplication.
Wait time.
Huh?
Wait time.
So take like 5 of each roughly. Maybe more. Just take it each. I got plenty of these. Huh? Yeah. That looks good. Make sure it's at least 5 of each. Yeah, I got plenty.
Darn it.
So, okay. You only got 3 of those.
Yeah.
You got good?
Oh, sorry.
Oh,
It's smooth. It would have been cooler if I would have made it. It would have been like aggressive.
Oh my god. I care about that.
Yeah.
It's cute. Honestly,
Yeah.
it does, but I still don't want it. I mean, I'm so happy. He also
Very
said that really, that was so sweet.
Yo, it's supposed to be what I was really fine. I mean, how one of those braids. I do
Oh, jeez.
soft because I'm not.
Oh no.
And
Yeah,
You
let's
can
just,
just
I'm
know
just
what
taking,
it
I got a
is.
bunch, just taking.
Could have been so enough, damn it. Could have been so enough. I can't believe she. I just realized myself.
Alright, so do a few things for me. I'm gonna progressively make these harder. So let's see. I want you to do we'll start off nice. -3 plus 2. Represent that.
The red for the negatives.
Huh?
Red for the negatives, right?
Reds are the negatives. And then it should be black, but the closest I got is the blue. Is the positive, yes. And if somebody wants to show me, come on up.
Oh.
Whoever, yeah, come on up. You can do the next one, Eric.
I'll take the one after her.
He's like, the next one's probably gonna be hard.
Is that, yeah. Where do you want me to do it?
Right here.
Very texture.
I'll just stand right here and stare at you.
Two ones I have these reactions, but I'm so sad and upset.
Alright, good. Awesome. You're gonna get -1. Cool, okay, I love it. Shaking ass. Alright, so that was negative, 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 positive, positive. These kill each other, you get 1 negative.
Mortar.
Ned.
Yeah.
What about this here?
Alright, you want like?
What's up?
Oh, I can go and do it.
Come on. Walk slow so everybody's got a chance.
Wait, yeah, go up slow.
This one's much more direct, yes? We know mathematically they're the same, we know that, but physically they're different. What do you think?
Oh, reds are, I grew up learning that.
Reds are
The
negatives.
Blues were negatives.
No, red, you're dead.
Red, you're dead, exactly. So
So
like,
you got the 3 negatives. It was add, maybe, ooh, 1 negative.
no.
Wait,
Help them out, class.
And then you gotta throw some positives in.
No,
Oh,
no, no.
no, think of it like this. You're taking 2 away, so you're taking -2.
There we go.
yeah.
There it is. I like it.
Really?
So fundamentally, this is a subtraction problem, yes?
Yeah.
Yep.
Just making sure. So it starts off with -3, yes? Put your -3 down. It tells you to take away
Take away.
2 negatives.
Yes. Precisely.
You with me?
You have 3 reds, take away 2 reds.
You just take away 2 negatives, and the answer is -1. So again, this is very important. This has happened to us before, and this is the misunderstanding of some parents. Sure, we now know these problems are the same. Physically, they're very different. Yes? This one involved me adding some stuff in. This one is more direct. It's just saying take away 2 of the things you had. You guys sort of with me, okay? Alright, so let's step it up a bit. Let me write it down. Well, if you want to come up, so these will go away. Alright, here, you ready? I'll let you think about it. -3 minus 2. So think about it, because this is a subtraction problem, right? What does it want me to take away from -3? 2 positives. So think about it.
Now we we're no.
And then how?
Go.
I already did.
Oh.
I got it.
Come on here. Alright. I've got chips up here, by the way. You don't have to bring them, or you can bring.
Why are these ones smooth instead of rough? I did the problem in my head to make sure I got the right number.
Somebody brought in sandpaper. I don't know.
Okay.
Alright, what you
So, start off with 3 negatives,
got? I like it.
and then take away, or to, you gotta add positives, then your answer is -2. Now, take the negative.
Alright, I like it. I like it. So right here, this step, of course, this is where you start. The only way to bring in 2 positives is to bring it in with a 0 pair. Then you're able to take away 2. Kick ass. I love it. Kick ass. This dude, yeah, here's a smooth dude. No, this is just a weird one. Okay.
Yeah, I know.
This one just came back from vacation. It's got a nice thing.
Got a little
Um,
tan.
Yeah, exactly. Alright. Alright, so this would be 3 negatives. Then I have to introduce 2 positives, and then I end up with 1, 2, 3, 4, 5 negatives. So I get -5. Kick ass. I like it. So let's go to the next level. How would I do 3 times -2? Now this might be where some of you guys need more negatives. Let me know if anybody needs more negatives.
I need more negatives.
I got so many, just take many.
I don't know what's positive.
Oh, I'm sorry. Look at me go. Need more negatives.
3 times 2.
No, we don't need any more negativity.
More negativity.
Do you not have more?
More negatives just because, I'm sorry, I just messed up. What do you got playing?
We're doing bigger numbers?
Preach. Multiple, yes. You might not need.
I mean, honestly, what my brain works.
They're
on
not
is
toys, they're
3 groups of
manipulated.
negatives. He said there's what? Like 3 groups of negatives.
They're not dolls, they're action figures.
Did you say these are not toys or what?
They're not toys, they're manipulated.
They're meant for manipulation. Alright. Who's got this?
I think I do.
You went, Eric. Who hasn't gone yet that wants to go? Anybody?
Mondo, go up there, solve it.
Do it. You got this. You got this. He has coins.
Okay.
Yeah, it's the coins up there.
It's alright. You can use this.
I want to use mine.
I don't blame him. Can't
Oh,
trust
sure,
me.
it's all tight. I didn't think I was gonna get up. Okay, so what we have here is 3 times 2 negatives. So I got all my negatives. All right. 2 negatives times 3. That's what I'm thinking.
I love it.
How does that sound?
Kick ass. And then you get
And then now I have 2, 4, 6.
kick ass. Alright, sweet.
Yeah.
Kick
Yeah.
Yeah.
Thank you, Mondo.
You're welcome.
White shirt Mondo. Now, alright, so I should have made this real clear. When you came up, Mondo, was there anything on the paper at first? No, it was a blank slate, correct? So this says drop 3 groups of -2, correct? That's what that says. So what is this? How do I do this?
Same thing.
No? The first one is 3 groups of -2. In fact, isn't the 3 positive in the first one?
No, 2 groups of -3.
The 3 is positive in the first one, correct?
Yeah.
Let's add 3 groups of -2. Who thinks they understand in English what the second thing says? Yeah.
It's like the array method almost. It's 2 groups of, yeah, 2 groups of 3.
Not really.
No.
2 groups of 3 would be 2 times 3.
No,
Negative
2 groups of
negative
-3.
of three.
That would be 2 times -3.
2 negatives.
Now, real quick, guys, you're fine. We know mathematically these are all the same. So this is where I understand getting frustrated, but we're looking at it on this side. Students who are learning this stuff are looking at things as very physical situations, and they see things physically different. That's the step you have to really understand. That's what the parents don't get. Is sure, we know that it's the same damn problem I just wrote twice. You just wrote the same problem twice, Jeff. But the physical nature of this, so let me show you. That says, take away 2 groups of 3. Do I have anything on the paper right now? So how do I put 2 groups of 3 positives down if there is nothing here?
You gotta do the translation thing.
So you guys, I don't know if you guys have enough. I should have given you more, but it's too bad. I'll just do it. Is this 1 group of 3 positives? Do you see 1 group of 3 positives?
Yeah.
Is my paper still blank, technically?
Yeah.
Yes, so I haven't changed anything.
Right, because you got zeros.
I'm gonna put another group of 3 positives. Bless you. Now again, I really think you most likely are not as fascinated at this as I am, and I'm sorry for that. But this is really kind of cool. Does everyone really understand that my paper is still basically blank?
Yeah.
Because I have a bunch of zeros, so there's nothing there. But am I able to take away two groups of 3 now?
Yes.
And the 3's positive, correct?
Yes.
So I'm going to take two groups of positive 3 away. And then what am I left with? What am I left with? Which is how many negatives? 6, negative 6. Okay. And I love it. I love it. Right now you're all like, yeah, dude, I knew the freaking answer was negative 6. Give me a little minute. You guys try this one. I'll give you a different one. Try this one. I can't really do too many considering how few you've got. Let me see. I can't. Do you guys have enough to do?
Not really.
Probably not. Negative 2 times 4. If you need any more, just come up and grab them. I got plenty. Yeah, so what does that say in English? I want to take away 2 groups of positive 4. I love it. And I've got nothing. I've got nothing. I want to take away negative 2 groups of times 4. I want to take away 2 groups of 4.
So you add eight zeros and then separate the zeros out.
That's what I was thinking, is that correct?
That's
So here is, have I added 1 group of positive 4?
Yeah.
I know I've done more than that. I added 4 zeros, but did I add 1 group of 4 positives? Yes. So I'm going to add 1 more group of 4 positives.
So you're thinking of 4 positives, then why are you adding 4 like in zeros?
So
Or like zeros?
at the beginning, what is here?
No.
Nothing. Anything I do cannot change what's here. This problem says, okay, you've got nothing, and I want you to take away 2 groups of 4. So let me go back real quick. I love this question. I want to make sure you guys are with me.
There's
on
like
this.
an imaginary zero?
This one. Mondo, you did this one, right? What was the first thing you did on this one? You remember?
I put 3 sets of negative 2.
Good, because right now, what's down here? What's on my paper?
Nada.
Nothing. This tells me add 3 groups of negative 2. All right. 1, 2, 3. I did it. I added 3 groups of negative 2, correct? You with me? So I did what it wanted me to do. This one, this little asshole here wants me to take away 2 groups of 4, and I'm like, listen, I ain't got shit. And he's like, all right, give yourself some shit. So what do I have to? And when I give myself stuff, I cannot change the fact that I have nothing. I have nothing, but I got to take away 2 groups of 4. So how can I add anything? Is just by putting 0 down. Don't I have a positive and a negative? So that's 0. I haven't done anything, but now I have chips I can play with. So I'm going to give myself, of course, 1 group of 4. That would be good if it was negative 1 times 4. But I need 1 more group of 4, and the only way to make it legal is to actually make it 0 that I'm adding. So, I still have 0 here. But am I able to take away 2 groups of 4 now? Yes, I can take away 2 groups of positive 4, and I'm left with
-8.
-8, which I understand. I'm not sure if you guys are really with me on this or not. This is where a parent would go, what are you people doing with math? But this is the physical interpretation of what this means. We don't want to just sort of say, it's great, you got the physical, no, now we gotta do some conceptual stuff, forget about that, no, we gotta bring them, they like the counting trucks, they like the stuff, they wanna keep doing that. Okay. Let's see, let's do blah, 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 yeah. Oh, let me ask you this little side note, now that we're talking about multiplication. So remind me, what's negative 1 times negative 1?
1.
Positive 1, I love it. What is negative 1 times 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 negative 1? How do you know?
They cancel each other out.
Oh, no, it's negative 1.
There it is. So every pair, of course,
0, 0,
1, 1, 1.
not 0, but 1, right? So 1,
Oh, yeah.
1, 1. So you get 1 negative left alive. How many negative 1s were there?
7.
7. So any odd number of negative numbers multiplying, gonna be a negative. Any even number of negatives multiplying, gonna be positive. So what is negative 1 to the 4,709 power?
Negative 1.
Yeah, because you got an odd number of negatives to multiply. Yes? You can see that?
Any odd numbers?
See again?
Any odd numbers what?
If I have an odd number of negative numbers multiplying, the answer will be negative. So, because every pair, so if I had 5 numbers multiplying, 5 negative numbers multiplying, every pair, let me make sure I don't end up flipping you guys off. Every pair kills each other, and then you got the one guy left. Yes? So any even number of negative numbers, all the negatives that are there pair up and die. Poor little dudes. Okay. You guys with me?
Yes.
So if I have a problem like this, negative 1 times negative 2 times 3 divided by negative 6 times negative 1. First thing I do is 1, 2, 3, 4 negatives. So will the answer be positive or negative? 1, 2, 3, 4 negatives. Will the answer be positive or negative? Positive, because every pair cancels, right? So I know the answer is positive. Then I just do 2 times 3 divided by 6. What's 2 times 3 divided by 6?
1.
1, yeah. So you can take the sign and then do the numbers. Huh? How many negatives do I see? Every pair kill each other. So I know the answer is going to be positive, and then I can just do 2 times 3 times 6. Ignore the negative signs, because I've already figured out the sign. Yeah, good. Okay. All right. Yeah, let's talk about division. Division can get weird, we all know that. We did the missing add-in approach earlier. What's the analog for division? The missing, yeah, so if I want to do 15 divided by negative 5, that would equal something if and only if 15 equals negative 5 times n. Is that cool? The missing factor approach? 15 divided by 5 is the number that if I multiply by negative 5, I'll get 15. 15 divided by negative 5, right? So what do I multiply negative 5 by to get 15? Negative 3. I gotta multiply by negative to equal to negative and 3 to make it 15. I love it. You guys kind of okay. So you got the missing factor approach. But of course you don't want a student to rely on the missing factor approach forever. So pretty much I gave away the game just a minute ago. In terms of whether the answer is positive or negative, you just count how many negatives you got. If you have an odd number, it's negative. If you have an even number, it's positive. That kicks a lot of ass.
Good amount of ass.
How would you do this set method? Who's got that? You got me, so.
Should I go up and put it on the
Come
board?
on up.
Yeah, brother.
Brother. More somewhere.
Here we got. Six negatives. Then you divide them into 3 groups. Get to -2.
Sweet.
Yeah.
Okay. What's in the, anybody else do it a different way? So -6 divided by 3, if you put them into 3 groups, there's 2 in each group, so it's -2. Is there a different way to do that? How many groups of 3 can you make? 2. Remember that's the sharing versus measurement approach to division? You guys remember that? Like that's a long time ago, Jeff. So let's do this. I'm gonna show you a couple of videos.
Remember it has a week. It's not from last week, we don't remember.
I'm gonna show you a couple of videos, and then we're gonna call it a day. Let's see, here. We haven't seen the little kids for a while. Let's see what they're doing.
Let's see what they're up to nowadays.
Probably some kind of math, some weird dudes.
Where are
that
those
do
kids in real life? They're older now, huh?
Probably.
Yeah, it's funny you say that because I was gonna try to find out exactly when these videos were done.
2005.
2005?
I don't know, that's just where most of these videos come from.
Okay.
It just looks like.
I took a child development class from videos from the 90s.
Dude, I'm in one of just like, oh yeah, that's from this cutting edge research from
Oh.
it was like 1970. I'm just like,
Cutting edge.
1970. That's before I was born. That's forever ago. All right, so let's see what these kids are doing. Oh, I got to stop my video.